examples. In part A, they ask us to expand each logarithmic expression as much as possible and simplify. This expression does not appear to be a fraction. It is a product, has three factors, e to the third, y to the second, and z, all multiplied together. Each of the first two factors has its exponent as well, so we're going to be using both the product rule to split up the product into several parts, and then the power rule on each of those first two logarithms to expand them further and move the exponents down in front. Let's take a look at that. So the product law is the one that says the logarithm of a product is the sum of the logarithms. So we're going to have natural log of e cubed plus natural log of y squared plus natural log of z. I'll just put a bar through it so it doesn't look like a 2. So it's been expanded for sure. It's wider than it was before. And then each, like we said, of the first two has an exponent or a power. So the power rule says to bring the power in front of the logarithm, leaving us with 3 natural log of e plus 2 natural log of y plus natural log of z. And then we just want to see if we can simplify. These logarithms don't combine, they're different letters, and we don't know what y and z are, so we can't simplify there. But natural log of e is one of the basic properties. Let me write it up here. Natural log of e is actually equal to 1. That simplifies quite a bit. Let me just remind you why that is. This is since natural log actually means log base e, so log base e of e is the question, and this equals 1 because e to the power 1 is the same number as e. And that's what logarithms mean. What power of the base makes the number next to the base. So, in other words, natural log of e is the number 1, so this whole first term is really 3 times 1, or just the number 3. And that's simpler, so I'm just going to write it like that, natural log z, and the final answer then is 3 plus 2 log of natural log of y plus natural log of z. 2 natural log of y plus natural log z. Okay, so I'll circle that. All right, so that's part A. Part B has a quotient, division sign. So we're going to be using the quotient rule. In the numerator, there's also a product. Anytime there are two letters next to each other, we assume they're multiplied. And it also has an exponent. So this is actually going to be all 3 rules. Let's see if we can break that down a bit, starting with the quotient. Separating the numerator from the denominator, we'll have log of the numerator, x squared y, minus, because of the quotient rule, log of the number 1000. Okay, so we've used the quotient rule so far. I don't want to busy this up too much by writing the names of the rules, but anytime you're doing subtraction, that indicates you changed a division into subtraction, the quotient rule. Let's see if we can break that down further. We still had multiplication there, so this part is a product, logarithm of x squared, and then the x squared is multiplied by y, so as we did in part A, we can separate the times into plus of 2 logarithms. Keep this one minus because it wasn't part of the product. 1000, guess we don't really need parentheses around it. Finally, the x has a power on it, so we can use the power rule like we did with the 3 and the 2 in part A. And we would get 2 times log of x plus log of y minus log of 1000. And that's as expanded as it's going to get. There are no more multiplications, divisions, or powers. That's how we know we're done expanding. But there is a way to simplify, not the variables again, because we don't know their value, but the part that's a number. Log of 1000 is really log base 10 of 1000. Just write in the 10 to make it more obvious. And that has a value that's simpler than itself, just as written. The question is, when you talk about logarithms, always what's the power? 10 to the what? Imagine this were equal to something, what power would make 10 into 1,000? And I think we know that 10 to the third is 1,000. So since 10 to the third is 1,000, this number is actually equal to 3, since 10 to the third is 1,000. So this whole logarithm, I'm getting a little busy here. Let's just say this logarithm equals 3, and I'll just rewrite it over here. Since 10 to the third is 1,000, we have 2 log of x plus log of y minus the number 3. And that's because the 10 to the third is 1,000. So that's how it relates. I'll put the base 10 back in there so you can see where the 10 got into it. Okay, so that's part B. All 3 rules in action there, starting with a quotient and a product, then a power, and then some simplifying by knowing what logarithm means. C we don't have room for here, so I'll move to the side. C is a little unusual. It's kind of like B if you don't pay attention to this cube root, but it has a fraction, it has a numerator with a product and a power. It has a denominator, which also has a power. But the cube root is the part that's different from all the rest of the examples. So let's deal with that first. We don't have a rule for radicals on their own. We have power rule, quotient rule, and a product rule. So radicals need to be related to one of those in order to be simplified. And it turns out that cube root, not of this specific thing, but just of any expression, is the same thing as a power with a 1/3 as its exponent. More generally, the nth root of a number is that number to the 1/n power. This is an exponent rule for fractional powers. So radicals are fractional powers. So I know there's no a in this problem, but the entire inside part can be thought of as the quantity a. So if we think of that log base 2 cube root as really a 1/3 power, this problem can be thought of as log base 2 of the fraction 8z squared over x to the 4th, all to the power 1/3. So it's another way to write it so it looks like it would fit one of our rules, something with a power instead of something with a radical. So this is just rewriting the problem. I'm not really doing any logarithm parts to it yet. But now that it's a power, and that power is on the outside of the entire thing, we should actually deal with that first. Take the power, put it in front of the logarithm, and then we can break down what's inside. So we're going to have 1/3 in front of log base 2, 8z squared over x to the 4th. It's starting to look better already. There's no radical, and the fraction's sort of out of the way. So we can focus now on breaking this part down. This is similar to part B, like we said, it's a product and some powers. So all we need to do is be careful not to lose the 1/3. When we break down the rest of the logarithm, all of that answer that we get, that expanded answer is times 1/3. So starting with the numerator, log base 2 of 8z squared can be separated from the denominator by subtraction. Quotient rule says to subtract. And then this is still a product, and it's not a product with a square on the outside, it's just the square on the z. So I can't bring that 2 down, but I can break it up into 2 parts, part of which has z squared, and then bring the 2 down. I'll show you what I mean. This is log base 2 of 8 added to log base 2 of z squared. And that's the part that's going to have the 2 that comes down, but not this, minus log 2 of x to the 4th. Oh, actually, that has a power also. So why don't we bring down the 4 in front of that log 2 of x. And this, again, I'm still keeping it all in brackets. And so far, I broke up this product. Let's just show you where it's going on. And then this power ended up here, which is why it's in front. It's a power rule. Wow. There's still a little more to do. There's another power we haven't done yet. There are no more products, no more quotients. So I think we just have to do this power and then see if we can simplify any of the numbers. So log base 2 of 8 plus 2 times log base 2 of z, and then minus 4 log base 2 of x. Okay, looks pretty good. As before, expressions that are log of a variable can't be simplified because we don't know the number value of the variable, but this isn't a variable, it's just a number, so maybe we can simplify that. Log 2 of 8, let me work on that over here. Just put it in its own little box. Log 2 of 8 equals what number? Well, whatever number it is, it's something that you raise 2 to the power of that to get 8. And we know that 2 to the third makes 8, so that question mark must be a 3. It's not a question mark anymore. It's something we can guess by our experience with multiplication that 2 to the third power equals 8. So log 2 of 8 is 3. So let me write that over here. We're running out of space on that side. I'm going to move this out of the way. Kind of wanted to put it closer to the 3 anyway. So the reason this was 3 again, it was log base 10 of 1,000 equals 3, since 10 to the 3 equals 1,000. And that leaves us a little room to write our answer to this last one. So it's 1/3 of 3, right, from 2 to the 3 makes 8, plus 2 log 2 of z, minus 4 log 2 of x. Almost done. Whoops. 2 of x. And that's fine. You could, if you want, distribute the 1/3. And 1/3 times 3 is 1. So that would make 1. 1/3 times 3. 3's cancel. 1/3 times 2 is 2/3. Log 2 of z. And 1/3 times negative 4 is negative 4/3. Log 2 of x. I think that's the end. This would be the simplified form of that radical expression. All right, so we got a good workout on all the